Let me take you on a journey. Not through time and space, or across the world, but rather a journey on how I created my own runtime level editor for a game that hasn't even made it past the prototyping phase. If you've been keeping up with the progress on Project Concordia, you'd know that the game is still very much a work in progress, and I have no right working on something as frivolous as this when there is still so much left to be done. But, I don't know, I don't really have a good reason for this. Really, I just wanted to see if I could do it. A big motivator of mine was a desire to establish rules for designing levels, which would be represented as literal restrictions within the level editor. These rules are technically reflected in the design of the game itself, with things like the size of rooms, hallways, and doors being directly relevant when deciding the size of the player and enemies, as well as props that fill the space. Anyway, I decided that the first thing I wanted to establish was a formal grid system for walls. Currently, wall tiles are placed on a grid with tiles being a quarter of the size of floor tiles. The inherent problem with having such a small grid of tiles is that when working in Editor, it's hard to track where the floor tiles line up to. And additionally, there is lots of room for inconsistent tile placement. For example, should a wall tile be placed adjacent to the floor tile or on top of the floor tile? First, I experimented with dynamic tiles, having a single tile base that could be used for all wall tiles and would connect accordingly. You can see me here messing around with my first version of that dynamic tile base, but obviously I immediately fell into a bit of a pitfall. There really shouldn't be any instances where there are double thick walls, as the moment double thick walls exist, the map can be placed off-grid and is no longer aligned with the floor tiles. So, I looked into scripting in conjunction to Unity's existing tile map system, and I found that by simply preventing the user from placing tiles on grid cells that aren't multiples of 4, I could lock tile placement to the grid I wanted. I cannot stress how important this was for me. I tossed around with various systems for wall placement through the entire development of Project Concordia so far, including wall segments which felt too annoying to place, and a node-based system that would generate a mesh during runtime, which I ultimately ditched since it felt too complex for what I really wanted to achieve. Tangent aside, having this tile restriction on the wall grid gave me the confidence to go ahead with the map editor, adding in basic functionality like a simple camera and a check for whether or not the pointer is over any UI elements to prevent drawing while trying to interact with the UI. Alright, we have walls, now let's get floors. It's worth noting floors are drawn to a completely different grid and tile map, and this is part of what allows us to ignore worrying about collisions between the two tile maps. By simply adding a UI button that swaps which tile base is being painted and which tile map is currently active, we can draw to the floor tile map, and additionally we can erase from those tile maps too, which I added by just setting a specific tile map cell to null when holding right click instead of left click. So we've got the very basics of tile map editing, but these black walls and white floors look pretty terrible. Now, I'm not going to pivot into developing the wall and floor tile designs, but we can throw together some incredibly hideous prototype tiles to get a tile palette working. To load these in, I've created a paint palette scriptable object, which contains several bits of information, including the name of the tile, a display sprite for the button, and the tile base itself. By putting these all in a list, I can dynamically generate buttons that will change what tile we're currently placing and allow us to cleanly organize our options in a palette through the UI. Okay, this is looking pretty good so far. I mean, it's hideous, aesthetically speaking, but mechanically, it's serving its purpose well. Having to draw every tile by hand is a little laborious though, so I pivoted into implementing a box tool before moving on. By recording a start cell and an end cell, we can use the bounds to fill in a block of tiles. This on its own isn't perfect though. Wall tiles shouldn't behave the same as floor tiles in this case. Just locking the bounds placement to every fourth tile, like when we paint wall tiles, isn't enough to solve this though, since it wouldn't be useful when building a room, and thick 4-block wide walls can still be generated in this manner. So by shrinking the bounds by 1 on all edges, we can clear the inside of the box and force all wall tile box placements to generate an empty room. I think that's plenty about painting tile maps for now, so I think we should move on to another important aspect of the game, which is props. Terminology is going to get a little bit mixed up here, but for the purposes of the map editor, a prop is any object that is placed in the scene and will be translated to an individual object during runtime. basically any dynamic or static object that isn't an enemy. This includes doors, glass panels, equipables, and although not implemented yet, props like tables, kitchen counters, any normal furnishings you'd expect to see in a room. We can create a palette for these things, similar to the paint palette scriptable objects, but these will have to carry a bit more data, like the dimensions of the prop and any offsets for their placement. I'll explain the significance of these bits of data more once they're actually relevant, but for starters, you can already see the prop system in work with this ghost sprite displaying what prop is currently selected and previewing where it'd be placed. To represent props in our editor, I have simply created a placed prop prefab, which records some simple data about the object and displays it as a sprite. These are unsurprisingly placed on a left click and recorded in a list for later. You might have noticed that there is a distinction between standard props, equipables, and wall props. The main difference is that wall props must be placed in line with the wall grid. In this way, we can prevent any floating doors or glass panels that block the way. This is also where recording the dimensions of the prop is relevant. Originally, my plan was to have a collider on the placed prop, which would prevent other props from being placed on top of it. But my approach shifted when I realized props would be placed on top of walls, with no way to reconcile that conflict. My solution was to create an invisible barrier tile that cannot be erased or replaced and is placed under a prop, removing any wall tiles in the process. This uses the dimensions that I mentioned previously to calculate where and how the barrier tiles should be placed, and you can see here that it took a moment to get working correctly. In this case, the system I put in place to rotate wall props based on their location in the grid wasn't translating to the barrier tiles correctly, among other things. It's also worth noting that this system only works on objects with odd dimension sizes, as the center of the prop should make up a single tile. This is where that offset comes in, specifically for objects like the glass panels, which need to be 4 tiles long so that they can tile correctly along the walls. By having an offset of 1/8 of a tile, the glass panel can be centered on a single tile, and the barrier tiles beneath it can line up correctly. Last thing that needed adding was a way to move and erase props. By hooking into the right click, I set the pointer to raycast and locate the prop beneath it, and if found, it'd erase the prop and remove the barrier tiles. Moving props is similar. When the prop system is in select mode rather than in place mode, it can raycast to find an object and assign that object to be placed. It effectively places a clone of that object and erases the original one, but that is functionally identical to moving the object directly. The only issue with this system is that when an object is selected to move, it cannot be placed anywhere within its old dimensions, and instead must be moved somewhere else first and then placed back. This probably can be improved by erasing the barrier tiles when it's selected rather than when it's moved, but for setting this up as reasonably fast as possible, I opted against digging any deeper. Earlier, I mentioned a list that was storing the data for all these props. This list is particularly important as the way it's recording the data is intended to make saving and loading this information easier in the future. These props don't know what they'll become, only what space they occupy, their location, and if they are rotated. The idea is that this data can be translated into plain text rather than needing to be stored in a unique class object, which would make future custom stages a potential possibility. Even looking back at my earliest devlogs, I mentioned wanting to create a player-accessible level editor, both as a learning opportunity that can be translated into developing level editors for future games if I ever want to take that route, as well as for the sake of seeing how others approach the game with access to its creative tools. The map editor has been a huge undertaking for me, taking up a bigger portion of my time than any of the previous mechanics I've implemented into Project Concordia. So despite the fact it's such a focused concept, I'm going to leave the remainder of it for the next devlog, where we'll cover placing enemies, level data, and save and load functions, as well as translating the raw map data into a functioning playable map. With that, we've arrived at the end of another devlog. A huge thanks to everyone who watched this far, and as always, if you enjoyed the video, make sure you subscribe and turn on notifications so you'll be notified when the next devlog comes out.